Okay, I wanted to look at the rest of chapter 1, just go over some definitions that are related to misuses of statistics. And there are a lot of misuses that we actually don't go through in this chapter right here that, are out there. But this just kind of opens your mind up to be thinking about some of the different misuses of statistics that are present when you're looking at like samples or even looking at studies that people posted, the results, or where people got data from. So this just help you be aware that stuff's out there. The first thing, misuse number one, kind of a generic name here, but bad samples. And there are a lot of different types of bad samples out there. Specifically, we'll talk about some of the other ones later, like small samples. But right here, one of the most common ones is the voluntary response sample. So what a voluntary response sample is, okay, is where people volunteer their information. So like for instance, let's say you send a survey out to the mail that people had to respond to. Well, generally the only people who are going to, volunteer their information or answer that are the people who really care about the subject itself. Or maybe if you're doing a poll or something, and maybe you're giving prizes for people in the mall if they answer this survey of yours. Maybe you're like giving away a car if they do this little survey or something. They earn it in a drawing. Really, I mean, the only people who are interested in winning that prize probably are the ones who are responding to that. So voluntary response sample, definitely one of the bad samples out there, where you can only really speak to the people who you took information from. So it's only a small part of your larger intended population, really, that you're getting information from. Okay. Now, misuse number 2 that I have here is what we call a small sample. So small samples. Okay. And if you have a sample that's way too small, you should not be using that to make a prediction about anything. So this example that I have here is that there was a report where it was 67% of the students in a school were suspended at least 3 times. However, the school itself did not mention that the sample was only 3 students. So I guess 2 of the 3 got suspended, so that led to such a high percent. But that's way too small of a sample to use to make kind of a conclusion like that. So definitely small samples are a big problem. You want to make sure you have a big enough sample to talk about, to use for your conclusions. Okay. Now, the next thing here is correlation and causality. So we'll talk about this a little bit better, but correlation, and we do talk more about correlations in terms of like linear correlations later in chapter 2 actually, but correlation and causality. So what exactly are we talking about here with these two? Okay, well, a correlation is just some kind of relationship, statistical relationship between 2 variables. So often we see like a correlation between smoking and development of lung cancer. Okay, but just because as statisticians we see there is a connection, there is a relationship there, we can't say that one caused the other. We couldn't say, for instance, that smoking causes lung cancer directly. And the reason for that is, I mean, there could have been a lot of causes or a lot of factors that led to lung cancer, things that we didn't really even take into consideration with our correlation or whatever. So just because we do see the connection, we can't say that one thing directly caused the other, just because, I mean, there's no way for us to really know that as statisticians. And I always tell people, this is kind of like your phrase to remember when you're talking about this, but correlation, it does not, it doesn't imply causality. So correlation doesn't imply, does not, you can say doesn't mean causality, or doesn't mean it caused it, or whatever. Doesn't imply causality. So one doesn't mean the other, basically. Okay. And the next misuse right here is, we're going to say percents over 100. Percents over 100. So this is kind of a small, I mean, it maybe kind of makes sense to you, obvious thing. But if you have a percent over 100, where you're like giving a quantity that's over 100%. So, something that you're given. You can't give more than 100% of some quantity. 100% is everything, is all of it. So if you're saying like you gave 110%, that obviously would be fake. You can't give more than you have present. So that's one thing to be cautious of there. When you see percents over 100, now you can have like growth rates and decay rates and things like that are over 100. That's fine. But just when you're talking about like giving of something, or you have like a finite amount of something and over 110% of it, you definitely be careful of that. And while we're on percentages here, I did want to just briefly look at some percentage problems here while we're on this topic. So you're going to have a lot of problems where you have percents and in the homework, and you might have to take it of a certain number. So this one wants us to take 37% of 500. So the way you're going to do this on your calculator is change 37% first to a decimal. So the way you write 37% as a decimal is, if you have 37, right, like there's a decimal at the back of the 37, right? So let's say you have 37%. So 37 and then a decimal. Well, you just move the decimal 2 places to the left, and you'll get the decimal form of 37%. So 0.37 would be 37%. Okay. Now the word of generally means multiply. So we want to actually take 37% times the 500. So you want to do 0.37 times 500. So 0.37 times 500, and see what this result is. So you'll use your calculator to get this one. So we use our calculator here to do 0.37 times 500, and we get about 185 for our answer there. So 185 will be your answer for 37% of 500. Okay, and then this problem says convert 5/8 to a percentage. So if you look at a fraction, basically you can read the fraction bar as a divide. So it's like 5 divided by 8 is basically another way you can read that. Well, when you do 5 divided by 8, you're going to get a decimal number generally. Okay, so let's show you how you'll use that decimal number and make a percent. So 5 divided by 8, we get 0.625. So 0.625. Okay. Now what you're going to do is multiply by 100, or you can just say move the decimal 2 places to the right for this. So a lot of people are like, okay, multiply by 100, and then you add a percent sign, or just move the decimal 2 places to the right. So you get 62.5, and then don't forget your percent sign. So, okay. Now our last little example here, or 2 more examples. Convert 0.045 to equivalent percentage. Right there, let me move the calculator here real quick. Okay, so convert 0.045 to equivalent percentage. Okay, what we want to do here is just move your decimal 2 places to the right. We just did this kind of just now, so 4.5% will be what that would be as a percent. And then 83% as a decimal. I think we did this kind of a while ago too, but when you write 83, the whole number 83, there's a decimal like behind the 3, behind the ones place. So you just want to move that decimal 2 places to the left, and then drop your percent sign. So it'll be 0.83 with no percent sign. Okay. So just a little review there of percentages to help you out. Okay. Now we want to talk about loaded questions. So loaded questions. What exactly do we mean by this misuse right here? Well, sometimes the way that questions are worded can elicit certain responses. So let's take these two examples right here where we have the question, should the president have line item veto to eliminate waste? Okay. Well, when we rephrased this question, okay, we ended up getting 97% people said yes with this line. Now we rephrased it just slightly and said, should the president have line item veto or not? Okay. And only 57% of people said yes when we worded it that way. So, why do you think there was such an increase with the first way? Well, it's because when people think about waste, like eliminating waste, right? That sounds like a good thing. Let's get rid of waste. More people were liking the connotation of getting rid of waste, or the denotation, what do you want to call it, of eliminating waste. It sounded like a good thing. So more people were inclined to say yes. It's like the question itself was purposely worded so that certain responses could be had. And that's definitely something you want to be cautious of, especially if you're making your own survey. Don't, load your questions, or certain responses will happen more than others. Try to be neutral when you word your questions, okay? Number 7 says, number 7 is missing data. And I know we had some problems that we presented in class where we were talking about, why can't we reach the whole population? Well, there was a lot of reasons we couldn't reach the whole population. And one of the things y'all were talking about was that there are going to be students that don't want to give you their data, or don't want to, people that don't want to give you their information. And also there'll be people that you can't reach. And those would be where you're missing data. A common example that I use in class is the Census Bureau. A lot of times the lower income households don't actually return their census data to the Census Bureau. So they actually suffer from missing those lower income households information. So it's not as accurate for them in the lower income households. Who knows what reason, maybe the lower income families are just more ashamed of what they make, or who knows what the reason is, but definitely missing data. And I still think you can use your data even if you are missing some components of it, although you definitely want to maybe address that when you do your write-up or present your study. Now this one's a little different from the other one. It's similar to loaded questions in some ways, but this one is order of questions. And one thing that makes this different from the loaded questions is it's kind of an unintentional loading, unlike the other one is more intentional. So if you look at this right here, let's look at these two questions. So would you say that traffic contributes more or less to air pollution than industry? So we have traffic contributing more or less to air pollution than industry, okay? And then we changed the phrasing around and presented the question again, and we said, would you say that industry contributes more or less to air pollution than traffic? Okay, kind of the same question. We just changed the order of things a little bit in the question. But do you think that will affect the results, or the outcome will be different? Well, you might not think it would be, but when traffic was presented first, 45% of people blamed traffic and only 27% blamed industry. Whereas when industry was presented first, we had 24% of people blaming traffic and 57% of people blaming industry. Okay, so it does change. Whichever one is presented first is what this shows us is the one people more connect to or more go toward when they give their answer. Like traffic presented first, it got the biggest amount of percentage. When industry was presented as the first one, it was the one that had the most percent. So it's very interesting how sometimes you might not think like the order of something matters, but definitely in this case you can see it does. So it might be better to just kind of keep your questions not being specific, like keep it general or generic. What do you think causes or leads to most air pollution, or what do you think contributes most to air pollution? Maybe have like the people pick from an option, a series of things, or they can write in their own answer, whatever you want to say. That might be a better way to phrase this instead of like having the options presented in an order in the question itself. So it's definitely something to think about if you make your own questions somewhere down the line, like which one would be the better, or how would you phrase your question in kind of a neutral way to not make people go toward one or the other. Okay. This is self-interest right here, self-interest survey. Okay. Or self-interest study, I guess we'll say. So some parties with interest to promote will sponsor studies. And what we mean by this right here is, or a common one that's used is, who pays for the study being conducted. And a good one to think about is pharmaceutical companies and, doctors or whatever. Pharmaceutical companies will pay or can incentivize doctors or physicians to use their drug and hopefully get back good results from the use of it, because there's some kind of money involved too. The doctors are more inclined to help out the pharmaceutical companies. They've been cracking down on this over the past few years, so I don't think it's as big a problem as it once was, but yeah, it definitely is something that was an issue back in the day. So you always want to think about who is funding or who is operating or working behind the scenes to get this study done and to have good results. You always want to look for those those studies, those reports published where somebody did it that didn't have a stake in the company or didn't have it, they weren't getting kickback from giving the results and finding the information out. Okay, so always something to be thinking about, like where did this study come from, who funded this study. There's a lot of factors that go into that, and always just being aware of these ideas can help you sometimes understand hey, there could be something going on here fishy behind the scenes, and you definitely don't want to you don't want to listen too closely to something that is probably biased or made up, or the results are not an accurate result. Okay, so yeah, a few other misuses here then as we go down. This is reported results. One thing, if you are studying something, you don't want to have people just tell you the data, especially if it's some big important study. And I use weights and heights here, for instance, because if you're doing a real study of weights, you want to try to get people on a scale and have them weighed yourself. You don't want them to just tell you their weight, because they could be estimating or even making up. Maybe they're lying about what they weigh. They want to weigh this amount, but they don't really. There's a lot of factors that go into that. You don't want to have people just telling you things, because it could be a lie. Okay. And this one right here is very precise numbers. This kind of goes for really, really large numbers, but your precise numbers, I would just be cautious of really large numbers that are so precise. Okay. An example here that I want to say is this large number here, 103,215,027 households. That is a very precise number of households in the United States. And I definitely think it's suspicious. Why do they have to be exact with that number of households? Why didn't they just say, there's over 103 million households or whatever? I feel like that would have been a better representation of that than just, giving this very, very precise number. It's just kind of suspicious. How do you know there's that exact number of households in the United States? Did you count them all? Where did that number come from? Yeah, you definitely don't want to do something like that, because it could be inaccurate. I mean, the number of households could have changed since you published this. So I would just say there's over 103 million households. That would be probably a better way to word that, and I don't think people would be as suspicious if you were there are about or there are, over 103 million. Something like that would be a better statement. Okay, I don't think it'd be easy to be that precise right there. And then the last one right here, the last misuse, is, we're just going to say bad graphs. Or actually, I should say misleading graphs. And there are a lot of examples you can probably find just by Google searching misleading graphs, graphs that were presented on news broadcasts that were wrong data, or they had the wrong percentages, like percentages that added up to more than 100. Like we said a while ago, can't have percents over 100. So lots of examples of this, but here's an example I have below on the next page, where we have this personal income per capita right here. And we have on the left, California and Nevada. We just have those two states, and we have 32,000 for California, 32,996 versus the 30,180 for Nevada. Okay, so not a big difference there, not a big jump, like 2,000, a little over 2,000 right there, jump, or almost 3,000 jump actually between the two. Okay, now look at the second graph. Okay. It's the same information presented, okay? So we have 30,000 for Nevada, the 32,000 number for California. But what is the difference? Okay, they definitely look different. And you can think about this yourself. Like, which one do you think is kind of misleading, okay? Which one kind of does seem like it could be saying something negative or different than the real picture, okay? And I'm going to lean toward the second graph here, the purple circle one. This one I think could be interpreted as misleading. And it's because the difference here is the author, or whoever created the second graph, chose to start at 30,000 as their number on the x-axis instead of 0. And what happened was it made the jump look really, really large. So to me, it says, it could be saying, I'm not saying everybody interprets it this way, but it definitely looks like somebody's trying to say you're going to be making more household income if you live in California versus Nevada. So it's kind of like you're trying to trick me here. It's the same information in both graphs, but I think the second one could be misleading. So I think it's definitely important, if you are doing your graphs, try to be conscious of, like, could this be misleading? And I would just try to start your axis, always begin it at 0 if at all possible. Okay. Definitely good advice to just start at 0 from your x-axis, or sorry, your y-axis in this case. I think I said x, but I meant y-axis there. Your horizontal, in this case, vertical axis. Try to start it at 0 so that you aren't being accused of, like, painting a picture that's not true or whatever. And then we have, like, this example down here, this next example, where people have used kind of this graphic money image in their picture, in their graph. One thing about imagery is it kind of clutters up the graphics itself, and sometimes it is hard to see, like, oh, where's the divisions come at? This one may not be that hard to interpret, but it definitely does take away or sometimes distract if you use too, like, crazy of imagery or whatever. You don't want to busy up your graphic too much. I think simple bars are a lot better, and I'll show you an example of that later. So try to avoid using, like, pictures or images with your graphs. Just keep it simple. And then this last little image kind of shows you how, like, volumes can be misleading. So, or like the picture representation of volumes. So if you look here, this, I guess, is people that earn degrees, how much money they make on average. So you have your no high school diploma making 18,000, and then if you look at the very last one right here, your advanced degree, they're making 74,000. I guess if they have a master's or a PhD, 74,000 per year on average. Now that's about four times as much right there that they're making. So the difference right there is 4 times. However, if you look at the volume amounts, like compare the volume amounts, okay, between this little small brick and this very, very large brick, okay, This is a 64 times difference right here. So 64 times versus, this is only 4 times difference right here. So very big difference between like what the pictures are showing versus what the actual numbers are. And this is why it's probably not the best idea to use like 3D graphics when you are setting up your pictures. So let's see, this right here, 64 times the volume of the first cube. So definitely something to be careful of right there. And then this is kind of an example of like just a good, easy graph right here. So this is good, perfect graph, simple bars, easy to read. The numbers are kind of stacked on top of the bar, just so you can kind of see where they stop at. Okay, real easy for somebody to kind of quickly look at and see. You can see it starts at 0 on the very bottom, so you're not trying to like paint a picture. You can't be accused of trying to say something that's not true. You start at 0 so everybody can easily compare everything. And yeah, simple and easy. That's all you need for statistics. Okay, nothing hardcore. But that's the misuse of statistics. Definitely the main thing to think about in this chapter is just always kind of be aware of what's going on around you. Is graph trying to say something weird? Did the data get collected in a weird way that used to misuse of statistics? Okay, was there some kind of weird source behind, like the funding of the study, of the research? All these things just to be thinking about. Was the sample too small? Was it a good sample? Was it a voluntary response sample that they collected the data? There's all kinds of factors to think about. Always just be mindful when you're looking at any kind of study, or even collecting the data yourself. Always be mindful of these various misuses. Okay, and that's all I have for that last little section of chapter 1.